There's a question that's come up on Quora a couple of times. Maybe somebody asked it once and it got a lot of answers, and the Quora prompt generator thought, ooh, that got a lot of answers, I should ask the same question again. Maybe lots of people asked it. Either way, I think it's fair to answer it in video form. The question is, if Earth is going around in big circles around the Sun, how come the view of the stars doesn't change? It's a fair question. Consider 1, 2, 3 clusters of berries. If I move the camera, that's you, around in a circle, apart from the direction changing, the view of those three relative to the others behind them changes quite a lot, and the angles between them, this angle here, this angle here, this angle here, but also that angle, and that angle, and that angle, they all change. So how come the Earth can be going 300 million kilometre wide circle around the Sun and the view of the stars doesn't change? Fair question. Now the answer to this is, of course, one of every flat earther's many weaknesses: scale. It's one of those things that I think doesn't get taught in school. It needs to be mentioned just once. The teacher stands up at the front of the classroom, holds up a Gallia melon in one hand and a ping pong ball in the other, and moves the ping pong ball in a circle around the Gallia melon and says, the moon goes around the Earth like this. They're not getting the scale right. And I think that's how you lead to people not understanding how a full moon can be fully sunlit, because shouldn't it be in the Earth's shadow? Well, no, because that ping pong ball should have been 4 metres away from the Gallia melon. In the case of a view of Polaris, or Orion's belt, or the whole of whole of Orion from Earth, we're talking about a star 400 light years away. Light year is the speed of light times a year. A year is 365.25 days, which is roughly 3.5 times 10 to the 2. A day is 86,400 seconds, mean solar day, which is roughly 8.5 times 10 to the 4. Speed of light is 299,792,458 metres per second, roughly 3 times 10 to the 8. Meters per second. If you multiply 3 times 10 to the 8 by 3.5 times 10 to the 2 by 8.5 times 10 to the 4, you get 9 times 10 to the 15. Earth going around the Sun. 300 million kilometres sounds huge, right? It is, especially compared to like a house, but or just the size of the Earth or the Earth-Moon distance. But you get to see how the view of the Netherlands changes. I'm walking. I'm not just trying to stay away from the people so I don't confuse them. But when you compare 300 million kilometres, 3 times 10 to the 2 times 10 to the 6 times 10 to the 3 metres, that's 3 times 10 to the 11 metres. And the distance to Polaris is roughly 9 times 10 to the 15. Some stars in Orion are closer than Polaris, some are farther away. Shouldn't moving sideways cause the view to change? The ones that are nearer go from one side of the one that's farther away to the other side of it. Well, let me illustrate that using an ordinary British pound coin. And a fence post with a split in it. See, 9 times 10 to the 15 divided by 3 times 10 to the 11 is roughly 12.6 million. 12.6 million multiplied by the width of that coin is roughly the distance to should have brought a feather so I could point at this for you, but just there. Where's Roger from Mudfossil University when you need him? Just there is the White Horse. I was kind of hoping to use the coin as a measure, but the exposure's all wrong. So, because the White Horse is at the near corner of the North Yorkshire Moors, that hill is a whole lot closer than that White Horse, and these hills on the south edge of the North Yorkshire Moors are a whole lot farther away. I'm going to hold this camera over there where you can see the white horse. I'm going to attempt to move it 2 millimeters sideways, the width of that coin. Ready? How much did the view change? I'm going to move you back now. How much did the view of the distant hills change? That is how much the view of Orion, or Polaris, or the stars around Polaris, or the Pleiades, whatever, anything at about 400 light years away, ought to change due to the Earth's orbit around the Sun. Right. Just that much. Just there. I hope this has adequately answered that question.